is probably a good time to do a little short segment, public service announcement, we could call it, about safety with this kind of equipment. Now, as things generally go, this piece of equipment is a little safer than working, say, on a vintage television, but it still has potential to kill or injure. So, and you understand, I'm not talking about you or me. I'm talking about those other people who are smart enough to kill themselves, but not smart enough to listen to safety instructions. But the basic issue is, if you're learning all of this on your own, I recommend you not work on any piece of equipment until you find yourself a mentor with experience in the field. That can either be one of these training courses that teach electronics, or including some lab work and so on, or it can be maybe a local ham radio operator or somebody who's working a TV repair shop or anything like that, because these are dangerous and you can hurt yourself. There are even situations in which you can kill yourself with these. So please be careful and tell those other guys to listen to the safety instructions, because they are important. While I was testing that Type 83 from the B&K on this Hickok tester, I realized that the tester wasn't working. That is, the Hickok here wasn't working correctly. So I pulled it apart, and I think I found what the problem is. So let me show you what it is. Okay, here is the 600A removed from the carrying case, and the problem is right here. This power resistor is broken right at that spot where, whoops, where that line is in the center. And that resistor is supposed to consist of 3 sections. Section 1 is from here to this tap, then a resistor from that tap to this tap, and then a 3rd section from this tap to the end. Well, both of the outer sections work okay, but this intersection, which should have about 7,000 ohms, is completely open. So what I've done is, for test purposes, I've put 2 15K 1 watt resistors in parallel here to give me about 7,500 ohms. And the tester now works okay. But what I'm going to do now is replace those resistors with a set of little better resistors with a little more heat handling capability. What I've done is I've put a 9K 10 watt resistor in parallel with a 33K 1 watt resistor, which should give me enough power handling ability to replace that power resistor. And I'm just going to put it in place of those 2 15Ks that I have paralleled up right now. And then we'll check out the tester and see whether it's still calibrated or whether that affected the calibration. I'll also show you a little where that is on the schematic and why it was doing what it was doing. Okay, there's the new solder pair or resistor pair soldered in. You may notice also that there's a jumper across that first section, that is from here to here. That was put in by the factory, so I'm going to leave that in, and this will put 7,000 ohms between here and here. And the way I determine 7,000 is that the total resistor is 8,500. The resistance from here to here is 1,500, and so I needed 7,000 to finish the resistance of this section. We'll see if that works. If not, we can always adjust it, and that's the reason why that I parallel with that 33K, so we can adjust pretty much anywhere we want by changing out that resistor. Now let's take a look at it on the schematic. Okay, here's the resistor on the schematic. And you may notice right here that this bottom section is shown shorted right there. And then there's a tap. Then there's a second tap, which is where C2 connects. And then it goes to R7, which is an adjustable resistor for calibrating. And that's here. This end is the ground end that's jumpered. And then the center where C2 connects is that blue and white wire there. And then this end, which is connected around to here, is the top end that goes to the adjustable resistor. I wanted to show you something that I really messed up on while I was replacing these resistors. And that is, when taking out the old resistors, I used this, what's called a solder pult or a solder sucker that works by pushing this down, and then you push this lever, it sucks the solder up through this end of the tool. The problem was, what I was doing is the amount of solder here was pretty high. And as I was sucking the solder, most of it would go up in the tool, but some of it would fall down. It turns out it got all over this particular switch right here. And then I had to go in with a little tool and pry the solder out. It actually got down inside some of the little sections of the switch underneath these contacts. It really made a mess. Fortunately, I was able to get it out, but the lesson, and I should have known this because I've used these tools a lot before, is they're really made to work with printed circuit boards like this, where you use them down on top of pins and things like that. You really shouldn't use them in a place like this. And I should have known better. In fact, what you should have used is solder wick, because solder wick will pretty much soak up everything that's there and also keeps the molten solder in place. But anyway, it cost me quite a bit of time on this, but I finally got it fixed. So now we'll put this unit back together and hopefully we can go back to working on the B and K.